Hey guys, so today we are going to look at inverse trig functions. We're going to look at the graphs just a little bit just to kind of visualize them. I'm not going to expect you to graph on your test. I just want you to understand why we do certain things that we do. Okay, so let's think about an inverse function. Okay, so remember that an inverse function or a function has an inverse if the function is one-to-one, right? So a function has an inverse if, well, and only if it is one-to-one. So remember what it means to be one-to-one is that it passes the horizontal line test. Okay, but remember, if it doesn't pass the horizontal line test, we can find an inverse of it if we restrict the domain. Okay, so remember, if you restrict the domain, so if you restrict the domain, you can find the inverse. Okay. Okay, so we're just going to look at graphing. We're going to look at your sine and your cosine and your tangent graph. And we're going to talk about the inverse of it, or the arc. Remember, arc sine, arc cosine, and arc tangent are the same thing as an inverse function. Okay, so I went ahead and drew a standard sine graph. So if I were to draw a horizontal line through this graph, it does not pass the horizontal line test. Okay. If I restrict the domain between 0 and 2 pi, so 1 period here, right, it still will not pass the horizontal line test. Okay. If I restrict it from 0 to pi, it still won't pass the horizontal line test. If I go from 0 to pi over 2, it would be just that little piece right there, right? But what if I went ahead and just from negative pi over 2 to pi over 2? What happens there? So I wouldn't have any of this graph right here. So my graph would look like this, basically. Okay, so if I restricted the domain in between negative pi over 2 and pi over 2, this sine curve would have an inverse. Okay, so let's think back when I told you that the inverse sine function lives in quadrant 1 and quadrant 4, and it lives in between negative pi over 2 and pi over 2. So this is the reason why this is happening, is that we have to restrict the domain to be able to find an inverse. Okay, so this function would not have an inverse if it did not restrict the domain. Okay, so if I restrict the domain to just be negative pi over 2 to pi over 2, then what would my range of values be for my regular sine curve? They would go from negative 1 to a 1, right? Good. Okay, so I'm going to use this little expo marker so maybe you can see this right here. So basically I'm restricting it to that little part of my graph. Okay, so if I were to take this information and draw my inverse, what does that mean? So I am going to restrict my domain. My x values are going to be negative pi over 2. My next one is going to be a 0. And the next one is going to be a pi over 2. And the y value, this one is going to be a negative 1, a 0, and back to a positive 1. Okay? So if I wanted to graph the inverse, so there are a few things that we could call it sine inverse of x, or we could call it arc sine. Remember arc sine? Those two things represent the same thing. Okay? So when we do this, what happens? Remember, your x values become your y values become your x values. So here I'm just going to flip-flop these. So my x's now are going to be negative 1, 0, and 1. And my y values are going to be a negative pi over 2, a 0, and a pi over 2. So I'm going to have a negative 1, a 0, and a 1. And my y values are going to be, let's call this pi here, pi over 2, and negative pi over 2. This is your y side, sorry, this is your x. So at negative 1, you are going to be down to at negative pi over 2, 0, and at 1, you're at pi over 2. So your graph of your sine curve, your inverse sine curve, is going to look like this. So the domain for your inverse sine curve, okay, your domain is going to be between negative 1 and 1. Your range is going to be between negative pi over 2 and pi over 2. Good deal? So that's what we're going to have to do for cosine and tangent as well. So let's look at cosine. So remember, I told you that inverse cosine lived in quadrant 1 and quadrant 2, right? Quadrant 1 and quadrant 2. Okay, so if I were to draw a horizontal line through cosine here, it does not pass the horizontal line test, okay? But can I restrict the domain so that it does pass the horizontal line test? Okay. So this would be quadrant 1. This would be to quadrant 2. So if I restrict the domain in between 0 and pi, right? 0 and pi, then I would have a piece of the graph. Yeah. And if I drew a horizontal line through it, it would pass it. So I'm going to restrict the domain to be between 0 and pi. So what's that? That's quadrants 1 and quadrant 2. Let's go back to so when I restrict the domain here, so this is quadrant 4 and quadrant 1. Okay. Then the range of values is the same, so it's from negative 1 to 1. So if I wanted to graph my inverse cosine function, so you could write it either way. That represents the same thing. So let's go up here and let's label our x and y's. So we've got a x, we've got a 0, we've got a pi over 2, and now we're going to have a pi. So at 0 we're going to be at 1, at pi over 2 we'll be at 0, and at pi we will be at a negative 1. So your x's become your y's, and your y's become your x's. So I'm going to have 1, 0, negative 1, and then we'll have 0, pi over 2, and pi. Okay. So at negative 1, we're going to be up at pi. At 0, we're going to be at pi over 2. And at 1, we will be at a 0. So this graph is going to be a little curly cube through here. So for your arc cosine graph, your domain is going to be negative 1 to 1, so the range up there, and then the range is going to be 0 to pi. Good deal. Alright, so what about tangent? Okay, so remember tangent, arctan, I told you that lives in quadrant 1 and quadrant 4, right? So if I were to draw a horizontal, it would touch everything. So it is going to be restricted to here. So if I restrict the domain here, this one's going to be open because I'm not defined at negative pi over 2 and I'm not defined at pi over 2. So the domain here is going to be between negative pi over 2 and pi over 2, but it's going to be open because it gets close and close and close, but it never touches. So remember, this is quadrant what? 4 and quadrant 1. The range of values for tangent, they continue to go, so the range is just going to be negative infinity to infinity. Okay. So let's look at some x and y values here. So if you had a x value of a negative pi over 2, undefined, right? But what about a negative pi over 4? I will be at negative 1. At 0, I will be at 0. At a positive pi over 4, I'm going to be at a positive 1. And then at pi over 2, I will be undefined. Okay, so we won't graph those when we're doing our inverse. Okay, because we're not defined here. Alright, so when we are going to graph our inverse tangent, so inverse tangent or arctan. Okay. So when we graph this, our x values become our y values. So negative 1, negative pi over 4, 0, 0, and a 1 and a pi over 4. Okay, so we're going to have a negative 1, 0, and a 1. We're going to have a pi over 4 and a negative pi over 4. Okay, so at negative 1, we're going to be at a, sorry, at negative 1, we're going to be at a negative pi over 4, 0, 0, and 1 and a positive pi over 4. So the domain here is going to be the range up here, right? So it's going to be negative infinity to infinity. So that means that this graph is going to continue on in both directions here. And the range of values are going to be in between negative pi over 2 and pi over 2. So it's going to be in between those two, right? So we're never going to touch this pi over 2 or this negative pi over 2. Good deal? Okay, so those are your graphs of your inverse trig functions. Alright, so I want us to refresh our memory a little bit of finding the inverse, like the compositions of our inverse functions. We've done this, we did that in, I think our first test, possibly, our first test. So I want us to look at this one here. So cosine of sine inverse of square root of 3 over 2. So where is sine square root of a 3 over a 2? And we can look at the unit circle here. So where is sine? At what angle is sine square root of a 3 over a 2? Pi over 3. So what is cosine of pi over 3? So cosine of pi over 3 is going to be at 1/2. Good deal? Okay, so this one, we could use the unit circle. So this one is using the unit circle. What about this next one? Number 2 here. This next one is not using the unit circle because this ratio is a negative 3 over 5. So I'm going to have to look at a triangle. So for this one, I want to draw a triangle. Okay. So where is cosine going to be a negative 3 over a 5? So inverse cosine lives in quadrant 1 and quadrant 2. But cosine is x over r, right? It's x over your r. So where is your x value going to be negative, in quadrant 1 or quadrant 2? Quadrant 2. So theta here is going to live in quadrant 2. Okay? So I like to draw my triangle. So if I drew my triangle this way, this would be a negative 3. Our radius is going to be a 5. So what value I'm looking for is my y value. Okay, so I will have a negative 3 squared plus a y squared is going to be equal to a 5 squared. So 25 minus 9 is a 16. The square root of a 16 is a 4. And I'm in the second quadrant, so y is going to be positive in that second quadrant. Yes? Okay. So if I wanted to now find sine of theta here, sine of theta is going to be y over r, so it's going to be 4 over 5. Good deal? All right, y'all do number 3 for me. So it's cosine of tangent inverse, so inverse tangent of 3 over 2. Okay, so inverse tangent lives in quadrant 1 and quadrant 4, right? It's only positive in quadrant 1. Okay, so this is saying that tangent of some angle is going to be the ratio 3/2. So what is tangent? Okay, tangent is x over, is y over x. So I'm in the first quadrant, so draw a triangle in your first quadrant. So that's coming from the origin there. So your x value is 2, your y value is 3, so I need to find my r value. So we would say 2 squared plus 3 squared is going to be equal to an r squared. So 4 plus 9 is 13. So r is going to be the square root of a 13. Okay? So now what I want to find is cosine of that angle. So cosine of this angle is going to be x over r. Going to rationalize the denominator, so it'll be 2 square roots of 13 over a 13. Okay, alright, let's look at 4 here. So 4 is sine of cosine inverse of 2x. So this one's a little bit different because now I've got a variable. So I still want you to think about it in your coordinate grid, but instead of having x and y and r, have a, b, and c as your sides and stuff, so you won't get confused with your x values.